Hello everyone, I am Shayok Kumar Thor, going to solve a problem that came on CSIR net. Okay, it's based on real analysis. So don't know how so easy question has come. It has been said that define a function like this. Which of the following statements are true? Okay, so my function is x into mod x. Okay, now we know that this function x, it is continuous. We know mod of x, that is also continuous function. Okay, so that's why now product of two continuous functions is also continuous. That's why this whole function becomes continuous on R. Okay, so that's why f is continuous on R. This is absolutely correct. X is a polynomial function and mod function this is. These both are continuous functions. So its product is continuous. Fine. Now look at this. Now I will check whether it is differentiable at 0 or not. Okay. I am just going to prove you that. Okay. Now look at this. Look at this. To check whether differentiable at 0, I have to check. I have to check limit h tends to 0 minus f of 0 plus h minus f of 0 by h, and I have to check limit h tends to 0 plus f of 0 plus h minus f of 0 by h. Is it not? To check any function is differentiable or not at some point x equals to a, I have to check just f of like this, f of a plus h minus f of a equals to f of a plus h minus f a by h. I have to check these two things. Now here my a is 0, I am checking at x equals to 0, so my a is 0. That's why I am replacing a by 0. I am replacing a by 0. Okay, fine. And now find its value. Now find its value. It's very easy. It's very easy thing. The limit h tends to 0 minus f of 0 plus h. It means f of h. Okay. So now what is your f of h? F of h equals to h into mod h. Okay. Minus f of 0. F of 0 means if you put 0 here, it will be 0. By h means this one. Correct. Now you tell me when h tends to 0 minus, h is just negative, just less than 0. In that case, if x is negative, since h is negative here, that's why mod of h equals to minus h. Okay, that's why I will put minus h in place of mod h. Okay, so it will be h, it will be limit h tends to 0 minus, in place of h I will write h into minus h, okay, by h, and in this case this h will be cut down, okay, and it will be, as h tends to 0, it will be 0. Fine. So it is its value is coming as 0. Now check for this one. For this one, limit h tends to 0 plus, again it is coming fh minus f0 by h. Fh means h mod h minus 0 by h. Okay, fine. So it will be like, now look at this. Now look at this. As h tends to 0 plus, so here my h is just greater than 0. Okay, since h is greater than 0, in this case mod h equals to h when h is greater than 0. So that's why I will just replace mod h by h. So it will be h into h by h, limit h tends to 0 plus. So it will be h will be vanished, and it will be, I will put 0 in place of h, so it will be 0. So in both cases, limit h tends to 0 minus and limit h tends to 0 plus, both exists at 0, and both are same. Okay, that's why its limit exists. Now here limit h tends to 0 minus and limit h tends to 0 plus, both are coming 0. That's why I can conclude that limit h tends to 0, f of 0 plus h minus f0 by h equals to 0, and it means f dash 0. That's why f dash 0 exists and that is equals to 0. Okay, that's why it is differentiable. It is differentiable at r, at 0. It is differentiable at 0. So it is not differentiable at 0. It is completely wrong. Okay, and now look at this. If is differentiable not only at 0. If suppose my function hx equals to, okay, I am writing it like this. Suppose my function fx equals to hx into gx. Okay, fine. And suppose at x equals to a, hx and gx are differentiable. Fine. So it implies that fx equals to hx into gx is differentiable at x equals to a. Okay. If two functions are differentiable at some point, then product of these two functions is also differentiable at that point. Now look at this. X is differentiable. I have already checked it at x equals to 0. So I am checking for x not equals to 0. Okay, I am checking for x not equals to 0. Now x is differentiable at this function is differentiable at x equals to a, which is non-zero. Okay, again, so this is differentiable for any non-zero point. Again, this mod of x is differentiable at x equals to a, where a is non-zero. A mod of x is also differentiable at any non-zero point. It is only not differentiable at x equals to 0. Okay, so this one is differentiable at any non-zero point. This one is differentiable at any non-zero point. So their product, what is their product? I am erasing this one. So their product, it is x into mod x, is also differentiable at x equals to a, where a not equals to 0. So I have proved that it is differentiable at x equals to a, where a not equals to 0. That's why this product is differentiable all over of R. It is differentiable. I have already proved that it is differentiable at x equals to 0, and I am showing that it is also differentiable when x is not equals to 0. That's why this function is differentiable all over R. So it is differentiable on R. No, it is differentiable only at 0. This is wrong. So okay. So option 1 and 2, these two are correct. Fine. Okay. So to watch more videos like this, do subscribe, like, share and comment.